Hello everyone. Now we are going to see how the code is exactly going to work. Firstly, we saw the start screen. Now we have in the menu screen. Now when I go to the micro mode by clicking one, I'm able to set time. Let's set it for 30 seconds or 20 seconds. And I'm pressing this to enter. And we can see the fan running, signifying that the cooking has started and the process is taking place right now. I can start or like I can pause this cooking right now by pressing on button 5. Hello everyone. Now we are going to see how the code is exactly going to work. Firstly, we saw the start screen. Now we have in the menu screen. Now when I go to the micro mode by clicking one, I'm able to set time. Let's set it for 30 seconds or 20 seconds. And I'm pressing this to enter. And we can see the fan running, signifying that the cooking has started and the process is taking place right now. I can start or like I can pause this cooking right now by pressing on button 5. Hello everyone. Now we are going to see how the code is exactly going to work. Firstly, we saw the start screen. Now we have in the menu screen. Now when I go to the micro mode by clicking one, I'm able to set time. Let's set it for 30 seconds or 20 seconds. And I'm pressing this to enter. And we can see the fan running, signifying that the cooking has started and the process is taking place right now. I can start or like I can pause this cooking right now by pressing on button 5. Hello everyone. Now we are going to see how the code is exactly going to work. Firstly, we saw the start screen. Now we have in the menu screen. Now when I go to the micro mode by clicking one, I'm able to set time. Let's set it for 30 seconds or 20 seconds. And I'm pressing this to enter. And we can see the fan running, signifying that the cooking has started and the process is taking place right now. I can start or like I can pause this cooking right now by pressing on button 5. Hello everyone. Now we are going to see how the code is exactly going to work. Firstly, we saw the start screen. Now we have in the menu screen. Now when I go to the micro mode by clicking one, I'm able to set time. Let's set it for 30 seconds or 20 seconds. Clearly the preheat time is about to end. And still the working of the microwave oven is signified by the running of the fan over here. After the finishing of the convention mode, we are taken back to setting time for the actual implementation because the preheating is over. Now we can set actual time for the cooking to take place. I'm clicking on enter. Very similar to the micro mode and the grill mode, the timer is elapsing and we are able to see that our food is getting cooked. The oven is on. And if I just click on the start mode, which is at the end, just a heating for 30 seconds will take place. And now I'm going to stop it by pressing on button 6. So that is how the working of our project is going by using the microcontroller PIC 16F877A. Thank you.
To talk about the scope of the project, microwave oven is a very versatile kitchen appliance. It offers a whole range of use. It's used for reheating and cooking food. And here we have generated all these events in the lab, so no hardware real interfacing is done. To talk about the functional block diagram, like we have the microcontroller, the PIC genius, PIC 16F877A microcontroller here, and we have the different modules such as the fan, the buzzer, the CLCD display module, and the matrix keypad module, and we will be discussing about these modules in detail. Now, we'll be discussing the CLCD module, which is a critical component in our microwave oven simulation. This module is responsible for displaying essential information such as the cooking time, power level, and system status. So this code consists of two files, the clcd.c and .h, the source file and the header file. So in the header file, we define the CLCD control signals, including the reset, the enable, and also we also declare the data port used. So then we have the init display controller. In this function, we have CLCD write, which enables the user to enter the data. The CLCD write function handles the data transmission in the 4-bit mode. This function also includes necessary delays here to enable a stable operation. Now, we have the init CLCD function. This configures the data and control pins as the output pins and then calls the init display controller function. Then we have the CLCD push function, which writes a single character at specified addresses, while the CLCD print function is used for displaying the entire string. These functions allow us to show messages like cooking or with the time and the microwave on display messages. So by integrating the CLCD module, we enhance the user experience because here we ensure the clear and accurate information display.
Just adding new things in the CLCD write function. In we are actually sending the data as in a 4-bit mode. So in the first case, we are actually masking the lower 4 bits, and after the data has been transmitted, we are making the enable pin to low. Then we are again like shifting the bit position to the next 4 bits, so that the higher 4 bits are being transmitted right now, and we are setting the enable pin to be high so that like the data that is being sent to the CLCD is being read. We are setting separate instruction mode and data mode. As like for instruction mode, we pass in the bit 0, and for data mode, we pass in the bit 1, depending on what we want the character to do in the CLCD. Put ch is for separate characters, and CLCD print is for continuous strings of data. And going to the header file, we have actually mentioned different lines. So the different line starts at different address positions from 8, C0, 90, and D0. And this macro function is just defined that whatever value of position we give, it is going to be added with the first initial position so that we get the final value to be added. So there are 16 characters, which means like 0 to 15.
And another crucial input component in our microwave oven simulation is a matrix keypad module. This keypad serves as the primary interface for the user input. allowing the user to set cooking time, power levels, and initiate commands like start or stop. So here we have two files. We have the matrix keypad.c file and .h file. In the header file, we define the hardware connections and the essential macro definitions for the keypad. Here, the row and column rows are defined. The rows are set as outputs while the columns are set as inputs. So then we have two key states, high and low. These define the logic levels used for scanning. Then we have two behavior modes, the level mode and the state mode. The level mode continuously detects the key presses, while the state mode detects the key state changes, which is basically edge trigger detection. Then we have the all released mode, indicating that no key is pressed. Then we have the three LEDs, LED 4, 5, 6, which are used for visual feedback. Now, coming to the matrix.c source file, this implements the keypad scanning and the input detection. The init matrix keypad function configures the column pins as input and the row pins as output. Then it enables the port D pull-ups, and it also initializes the rows as high. Now in the scan keypad function, we use a row column scanning technique to detect the key presses. That is, each row is pulled low one at a time. So if a key is pressed, the corresponding column pin is detected as low. This function returns the corresponding key value, be it 0 to 9 or star or hash. Now, in the read matrix keypad function, the retrieval of the key press based on the specified mode is obtained. So here the mode is level. So the pressed key is returned here. That is how the matrix keypad function works. It helps us in obtaining the user's input. The timer module plays a crucial role in the microcontroller simulation. It manages the time-based operations such as the countdown timer and preheating duration. So, in the header file, we have the function for initializing timer 2. In the timer.c, the source file, we have the functions such as init timer 2 to select the p-scaler and reload the register. So here we also enable the timer to interrupt, and then we clear the flag in case of overflowing, and then we also define the number of ticks in the preload register. So this setup enables precise timing control. Here we have periodic interrupts for countdown and other time dependent tasks. Now to talk about the interrupt service routine. It contains the timer to interrupt handler. So this is the thing which updates the countdown timers. That is, if the timer overflow happens, that is if the count reaches 20,000, this indicates that 1 second has lapsed. So then the counter resets. And to talk about the countdown logic, it decrements every second. That is, for 1 second elapsed, the second is decremented. Then if the second is 0, but the minute is not 0, then we set the minute as 0 and set the second as 60. And then again the decrement continues. And then we have the preheat duration decrement. Over here, if the preheat time is not 0, then we decrement the preheat time to be 0. So here also we count down it. Then we clear the interrupt flag. So by this by this function, we enable precise second-based timing.
So now talking about the timer 2, we are going to discuss about the modes that we had set in this timer 2. So by setting the T out PS3, T out PS2, T out PS1, we are actually calculating the post scalar. Since all are 0, it is 1 is to 1. Depending on the value, like we can actually get it to like how many number of overflows it should go to trigger an ISR routine. For example, if I'm setting it as 2, after 2 overflows, the ISR will be triggered. And I'm turning on timer 2 by TMR2 on. Then C2 CKPS1 00 sets the prescaler value to 0. Prescaler actually divides the clock input before feeding that into the timer. And this is for enabling the timer interrupt and for clearing the timer to interrupt flag so that unwanted ISR is not generated. This denotes the number of ticks. So actually the time period in the timer is going to be calculated as PR2, the number of ticks that we select here, plus 1 into 4 into the timer's oscillation period into prescaler value, which happens to be 1 in this case.
The microcontroller file talks about the menu screen, which has four key options. That is the microwave mode, grill mode, convection mode, and the start option. So these are displayed on LCD, allowing the user to select the desired operation. One of the critical aspects of the microwave system is time setting. The user inputs the cooking time using the keypad, and the code ensures that the entered digits are correctly placed in the minutes and in the seconds format. So the system also additionally provides the user the ability to clear and confirm the input values using a star and hash buttons. So once the timer is confirmed, the microwave starts operation. It activates the fan and the timer. So in the header file, we define all the functions used as a clear screen function, which clears the display messages, and then we have the power on screen, which turns it on, and then we have the display menu screen, which shows the four modes, the micro, grill, convection mode, and the start option. Then we have the set time function, which enables the user to set the time in the minutes and second format. And then we have hit the foot function, which is on the fan. Then we have the time display function, which shows the remaining time left, and the set temperature function, which allows the user to set the temperature. Now, coming back to the microwave source file, here we have the functions. So, here we define the power using the power on screen. It prints the statement onto the LCD display. It prints the 15 bars like in the 15 positions, and then we have the clear screen function, which clears the screen and then induces a delay of like 500 milliseconds. And then the using display on the screen function, we print all the modes, the micro, grill, convection, start option. Then using set time, uh, we display the set time minutes, second format, and the user gets to input the value. And using the start, we can clear the input, and using hash, we can confirm the input by pressing enter. Then the fan is turned on here, then you confirm it, and then here it's converted into the format from minutes to second. Then using time display, we display the left out time, and we also display the four options: the start resume option, the pause option, the stop option. The start and resume works in an aspect of pausing the time and then restarting it again. The pause stops the time, and whereas the stop stops the entire operation and goes back to the main menu. So when the time is up, the message that cooking time off is displayed. Then in the heat mode, we switch on the fan and the timer is switched on. Then using set temperature, the user gets to set the temperature. But if the temperature exceeds 180, it's set as 180. So 180 is the maximum temperature. Then we also have preheating option where the time is set already. We set it as 180. The user can't control it and you have to wait until the time is up. So yeah, that is how the micro oven file works. Now this is the main header file. So in the header file, we declare all the modes here. We define all the modes, the micro mode, the grill mode, convection, start mode, time, display mode, stop, pause, the reset modes, and we also define the fan there as a register, and then we also define the on off modes and all the functions here. And in the main.c, the source file, here we have the init configuration function, which initializes all the buzzer and the fans. And then we have the main function in which we define all the modes based on the keypad, the key pressed on the keypad. And then in the operation call, using switch case, we choose the modes based on key pressed, and we also define each mode here. And using the power on screen mode, we print the power on message and the macro message, and then using the cooking mode display, we again display all the modes. Here display clears the display, and then use set time to set the time, and then using the formatted time display the leftover time, and the modes start, resume, pause, stop are defined here, and message of cooking time is displayed. Then we set the temperature, and that's how the main file works. So we integrated different modules here, such as the CLCD, the matrix keypad, the timers, the ISR. We have integrated all these to simulate the macro oven here, and we have successfully built the macro oven and simulated the same in the PIC microcontroller.
Finally, going back to what we learned from this particular project, we learned how to use different modules and interfacing them with a PIC microcontroller like CLCD and timers and matrix keypad. By defining these different modules, we came to know how they can be used and how they can be interfaced seamlessly, integrating them with our projects. And we also learned how to define custom like custom symbols like bar, which we had used here for the power on screen, for using them with the CLCD, which was comparatively very new for us. Setting of different modes, like making the blinking of the symbols in the CLCD, was all something that we learned newly through this project.